Hey, hi. Hi, everyone. Hello. It's me, Hitesh. So welcome to Data Desk School. Okay. So today we're gonna basically start with a one kind of an ED analysis using the Python. And the prerequisites for this so like before starting with this kind of an project, okay, you should know at least some basic concepts about the Python, like the loops, conditionals, like functions, okay, and some little bit knowledge about the visualizations also. Okay, if the basic knowledge is also there, that will be more than enough to cover up the things. Okay, so today we're gonna basically do one particular project which is said to be an electric vehicle market analysis. Okay, where we're going to basically analyze the market size using the Python only, and how we can able to like determine the some potentials sales volume between the given markets. Okay, so the guys, whenever we do the any kind of an market size analysis, okay, so our market size analysis, guys, is a very crucial aspect of our market research that will going to basically give the foundation and determines the potential sales volumes within a given market we are basically preparing for. So it helps us the like business to understand the magnitude of a demand, then assess the market saturations, then levels, and then identify the growth opportunities. Okay, so if you wanted to learn how you can able to perform a market size analysis of any kind of a product, guys, so this particular project is for you only. Okay, so in this particular session, I'm going to take you through all the tasks of electric vehicles market size analysis using the Python. Okay, and then basically some other problem statements are there. That problem statements, so we're going to solve it. Okay, so some of the problem statements I basically fetch it out from there, some doing any kind of research. Okay, so these are the guys problem statements we have, and we're gonna solve these statements only, and then we can like get to start with the things. Okay, so let's start. So guys, whenever we are doing the market size analysis, especially for the electric vehicles company. Okay, so here I'm doing the market size analysis for the electric vehicles company. Okay, so this market size for this particular electric vehicles company, guys, is involves a very a multi-step process. Okay, which includes defining the market scope, collecting and preparing the data, then doing the analytical modelings, then communicating the findings through the visualizations and reporting. Okay, so I'll basically tell you what are the multi-step process you have to do. Okay, so these are the some problem statements. So we have with us that is defining whether the analysis is kind of a global, regional, or focused kind of a things, or the specific countries it requires. Okay, and then we can also see that second statement is gathering the information about the industry associations. Okay, about the market research firms like Bloomberg, IFA. Okay, these are the some government publications are there. Then we have to basically analyze the guys, identify the trends in the electric vehicle sales and productions and markets. And then guys, we have to analyze the market size and the growth rates. And then we have to basically check out based upon the market size analysis. And we have to provide the strategic recommendations for the businesses looking to enter, expand in the electric vehicle markets. Okay. So for the entry level business startup also, okay, which particular constraints they have to basically decide on in order to enter in the market. Okay, so these are the particular problem statements. We're gonna solve it. So data set, I'm going to guys share it in my GitHub link with this video only, as well as the code and the problem statements in my GitHub repository. Okay, so from the GitHub, you can able to like fetch out all the data sets as well as the needed documentations, whatever you require. Okay, now let's start with the our actual thing. So we required guys our Google Collaborate. So I hope like everyone knows the Google Collaborate, where we basically do the all the Python operations and Python coding, a normal kind of an analysis, guys. Okay, so it provides our with a good infrastructure, like it also provides the CPU and the free number of GPUs. Okay, so if our data set is very big and we require the guys GPUs in order to run it, so we can able to use the free GPUs which is provided by the Google Collab. Okay, got it. So now we can able to start with the actual loading of our data sets. Okay, so I have basically downloaded one data sets for our the electric vehicles. Okay, it's a public data sets, guys. So let me basically uh like uh like upload the data sets here. Okay. So we're going to upload the first of all data sets and then we can get started. So let me see, where is my data? And then guys, we're gonna get like, first of all, what are the basic things you require of any kind of an EDA analysis? Okay, that particular things we're gonna do, like reading the data sets, then like talking about how we can able to basically do the EDA analysis. Okay, what is an EDA analysis? Or you can talk about. Okay, so these are the some basic things we're gonna basically do in our today's sessions. Okay, so let me import my data sets. So I have my data set guys with us. Okay, so now you can see I'm uploading electric vehicle population data sets, guys. So it's a CSV file. So what basically, guys, EDA analysis is does. Okay, so EDA basically it's termed to as a exploratory data analysis, where we have to basically do the uh, deep insights. Okay, whatever, whenever guys you required, whenever you want to extract some deep insights from any kind of a data. Okay, so you have to guys do the EDA analysis. It means you have to basically prepare the visualization through the different graphical methods. Okay, through the different visualization methods and techniques, you can able to extract the maximum amount of insights from your given data. Okay, that is basically said to be an EDA analysis. There are lots of factors affecting the EDA analysis. I'll make a separate video and session for the EDA one, how you can able to implement, what are the factors you have to consider on. Okay, so just like for the time being, you have to like basically consider this amount of knowledge only, like what is meant by EDA and how we can able to implement it. So whenever we got any kind of a data, we first of all used to read the data. Then we have to do the some simple operations like, guys, finding the null values, if the data contains some inconsistent values or not, if it is in proper format or not, what the data set is all about. Okay, so these are the some basic commonalities we have to basically follow on doing the EDA analysis. Okay, so let's start with our part. Okay, so guys, first of all, the first thing which we required are libraries. Okay, so in order to read our data set, we require the Pandas libraries. Again, it's a very, very important libraries for doing any kind of an manual, finding operation things. Either it is a you're having the CSV file, Excel file, JSON file, any kind of a files, guys, you have with you, a SQL file, you can able to basically manipulate with the Pandas library. Okay, so in order to basically start with the Pandas, let's first of all check out. Okay, we will install the Pandas libraries. So let's run this by using the pip install command. As you can see, I'm getting this kind of message that requirement already satisfied because I've already installed the Pandas library in my system. Okay, so you can able to like run this particular command and then you can able to install the libraries. And then we can able to start with importing the libraries, guys. So import Pandas SPD. So as you know, I'm importing my Pandas and I'm giving very aliases to my basically Pandas. Okay, aliases means suppose I don't want to basically use this Pandas again and again, okay, because this Pandas contain a lots of you can say lots of functions and attributes. You can say this kind of much functions and attributes it contains. Okay, so if I want to use this attribute, so I have to basically access to my Pandas, like Pandas dot and then function name. But I don't want to use again Pandas like in this way. Okay, it's kind of a big one, a kind of a repetitive one. So instead of Pandas, I'm basically want to use the PD. So that's why I'm giving the aliases here, Pandas as PD. Okay, so this is the particular functions I can able to see here. So let's first of all import our data sets. So I'll use the data set here. So let's import. So PD dot read underscore CSV. I'll use the function called as read underscore CSV because it contains, guys, a CSV file. You can see this is the CSV file. Okay, so I'm going to use the read underscore CSV function in order to read the CSV file. Okay, so let's copy the path and then we can able to set up the path, guys. If you want, you can take a different variable in order to set the path. So I've taken the path variable and I'll pass this path parameter inside my read underscore CSV. Okay, and then, guys, I'm going to basically read the first 5 data of my particular, in which particular data it is getting stored. Okay, so the first 5 records I'll basically check out in my particular data sets. So I'm using the head function in order to check the first 5 records, guys. Okay, so let's run this and then we're going to basically see the data, guys. So you can see this is my complete data I have with me, that is having the VN 1 to 10, then the country, then the city, then state, then postal code, then model, then year, the make, in which particular make it is there. Then we have the things like model, then electric vehicle types. So this is the guys, you can say different kind of an informations it provided. Okay, so VN 1 to 10 you can say as a partial vehicle identification number, guys. A vehicle identification number, you can have country in which a particular vehicle is registered, city, the city in which vehicle is registered, then state, guys, in which particular vehicle is registered. Okay, so it depends that, guys, this data basically focused on W, that is a Washington state, which is off on USA, United States, right? Then we have the postal code of that particular area. Then we have the model year, in which model year it has been generated or registered. Then we have the make, that is who have the maker, basically. Okay. Then we have the, guys, a model, the electric vehicle type, which kind of electric vehicle it have, BEV, different types we have. Okay. Then we have the, guys, a model year, and then can have the clean alternative fuel vehicle, guys, which is, you can say, then also we have the eligibility status. Okay, that whether that particular clean alternative fuel vehicle programs has been available or not. The electric range, the maximum range of the vehicle on a single charge. Okay, then we have the base MRP, the manufacturer like suggested retail price. Then we have legislative district, guys, means where the vehicle is registered in which district. Then we have the basically a Department of Licensing Vehicle ID. You can say DOL, Department of Licensing Vehicle ID. Then we have the, guys, a vehicle location. And then we have the electricity utility, like the service provided for the vehicle's location, and the 2020 consensus track. So these are the some, guys, columns we have inside our data. And this is the basically data we basically got it here. Okay. So the primary objective of this analysis will going to be the leveraging the historical EV registration data to understand the current market penetrations of several electric vehicles. Okay. In order to predict the future market growth, and also identify the key trends and factors and driving the, guys, market extensions for it. Okay. So the specific goal has to be included this only, like accessing the historical growth trend of EV registrations. Then we can able to, guys, forecast the future electric vehicle registrations based on the historical trend we have with us. Then we can able to analyze the distribution of EV registration across the different models, makes, and the geographical regions. Then we can able to estimate the market size and the growth potential of EV market. Then we can able to provide the insights to support the stakeholders and clients in decision-making process to related to the production, infrastructure, planning, and policy formulation. Okay, so these are the things like basically we're going to basically analyze in today's thing. So let's contain like what are the column information we have. So I'm using the EAV underscore data dot info method to understand the column information. Okay, so let's run this. So we'll get the all column of information, whether what is the data type of the information and what is content, guys. Object means a string, integer means integer value, float means, guys, a decimal point value. So you can see, and the size of the data is 23 MB. And guys, we got the data types here. So let's basically find out whether do we have the missing values in our data set or not. Okay, so I have the EV underscore data dot is null and dot sum, guys. So we'll find the, you can say, null values. Okay, guys. So you can see we have null values, quite of null values inside the country, city, and then postal code, model year, like not a model year, but we have in legislative district. Then we have the electric utility and 2020 consensus track. So we have the couple of null values and the missing values in our data. So like how we can able to deal with it. It's very simple. Let's, guys, drop our null values here. So I'll use the ev dot drop NA function in order to drop the null values, guys. So let's again check out our null data. So let's check it out. Is null dot sum, and let's check it out. Okay, perfect. Can you see? Now we don't have any kind of null values inside our columns, right? Now, guys, what we basically do, we're going to basically analyze the market size of it. Okay, so what I'm going to do here, the first of all, I'm going to start with analyzing the electric vehicle adoption over the time, guys. Okay, what is the basically over the time? I want to basically analyze that particular things. Okay, so analyze the, you can say, let's analyze, I'll say EV adoption over the time. Okay, over time by visualizing the number of EV registered vehicles. Okay, number of EV registered vehicles. Okay, registered vehicles by model year. So this is our particular first statement, what we're gonna solve here. Okay, so it will give insights into some how the EV population, electric vehicle population has grown over the years. Okay, so for this, are you going to use the visualization library called as a Matplotlib? Okay, then I'm going to use, guys, a second library that is said to be a Seaborn. So import Seaborn as a SNS for our specific, like, very good library that is advanced visualization. And then we can able to get started with the things. Okay, so if you want to download this library, again, guys, the same command, that is pip install Matplotlib and pip install a Seaborn. Okay, you can able to, like, run the command call as a pip install Matplotlib. Okay, and then you can able to run a pip install Seaborn, guys. Okay, so you can see these are the two commands that you have to run. If you want, I'll run it for you all. Okay, so let's run this. And in my system, I guess it will going to show requirement already satisfied because I've already downloaded the library, right? Now let's set up the background color. So by using the SNS library, I'm going to set up the, guys, a background color. So SNS dot set underscore style. Okay, and I'm going to set a style of white grid. Okay, so there's a basically a specific predefined styles has been given. Okay, so I'm using the white grid here. And then, guys, I can basically start with the visualization. So plt dot figure, I'll use the figure library in order to set the window, the figure size. That is, I'm keeping the 10:6, or you can keep, guys, height as a 12 and width as a 6. So first one is, guys, I'm going to take as a this one, EV adaptation over the years. So EV adoption by year equal to. So, guys, I'll use the EV data. Okay, inside the EV data, I'm going to select the model year. Okay, so I will select the model year from here. And then, guys, I'll use the value count. Okay, because in order to check out the frequencies, so I'm going to check out all the frequencies in the model year, and I'm going to basically sort the indexes, guys. Okay, so I'll sort the indexes. Then I'll use the, you can use the line plot also, but here I'm using the bar plot, and bar plot having the x-axis as this year. Okay, then it can have the, guys, y-axis over the like this one values. Okay, and the plate we can able to set as means marker. For the line we don't use the marker, we use the set the, guys, plates like the colors which you want to follow. So this palette I can set as a verdis, like these are some predefined palettes are there, so you can set as a verdis. And then you can see I can able to use the title, and then I'm going to basically use the, guys, how much rotation I want to use it. So model year, number of vehicles has been registered here. Okay, the number of vehicles has been registered, and the rotation, and then I can able to use the show command. So let's check it out. Hopefully I should not get any kind of an errors. So now, can I see all of you? So from this award chart, we can able to conclude here that it's clear, guys, that our EV adaptation basically has been increasing over the time, right? Specifically, if you're going to see, guys, there's some noticing, you can able to notice some significant upward trend has been starting around from 2016, I guess, right? So from 2016 only, it started some kind of an upward trend. The number of vehicles is getting registered grows moderately, guys, up till to the 2023, right? So in 2023, it shows a particularly sharp increase in the number of registered vehicles. Okay, begin with the highest on the graph, indicating a very peak of around more than 50,000. But if you're going to see, guys, over the 24, again it get decreased, right? So because we have the current data till 24 only, from 1997 to 2024, it has started with some kind of a mini peak at 2011, but the highest peak we can able to find on the 2023, right? So this is the particular analysis we have done, the number of registered vehicles over the time. Okay, now we can able to go to our second task. So what we'll do, we can do, guys, let's start like by selecting the top 3 countries. Okay, top 3 countries based on EV registration. Based on EV registration. So we are going to our this problem statements only, which we have basically defined. Okay, so based upon this registration, EV registrations, we're going to analyze the distribution of EVs within the cities and of those countries, guys, because you can say define whether the analysis is global, regional, or focus on specific countries. Okay, so we'll analyze the EV distribution within the cities of those particular countries only. Okay, So I'm going to basically find the geographical distribution of a country level. So let's basically check out the EV country distribution, EV country distribution equal to, okay, so I'll use the EV data for it. And inside the EV data, I'll use guys a country column, right? I want to basically go for the country dot value counts. Again, the frequency guys, value count is used to calculate the frequencies, the measure of frequencies, right? The relative absolute frequencies we calculate. So that basically counts by the value counts. Then I'm going to take the top countries. And from the top countries, I can able to use the basically a head column. Okay. And then I can able to set the indexes. Okay. And then I'm going to guys filter my data. Okay. So filtering the data set for these top countries only. Okay. This top countries. So I'll use the top countries data here. Okay. Top EV data. Let's give the some meaningful naming convention. Okay. So let it be. Now EV data I'm taking guys, EV data. Inside EV data, I'm taking the country column and I'm checking basically, isn't that in the top countries or not? Okay. So I'm basically just doing the some manual conditional formatting here. Okay. So I want to check out this country distribution in this top countries or not. Okay. By using the isn't function. Now analyze the guys a distribution of EVs within the cities of these countries only. Okay. So EV city distribution and top countries. So you can give the proper naming convention for the variable so we can able to understand. So top EV data of city dot values count I can able to do, or what we can able to also do guys, instead of taking the city count, okay, so I'll use the country and city. So I'll use the group by in order to basically group by the inside the country and city. Okay. So I'll use the country. So inside the country, I'll going to basically group by on the basis of city. Okay. The city. And then I'll going to guys sort out the values. So let's sort out the values. For this one, I'll use the size. And then I'll the sort value guys. Sort value. So this will going to basically gives the values in ascending. I don't want in ascending order. I want in descending order. So because by default, it saw the values in ascending order. So I'll set the ascending equal to false. So definitely it will going to give me in the descending order. And then I'll going to reset my indexes here. Okay. And after resetting the indexes, I can able to give the name as suppose number of vehicles. Okay. Number of vehicles. Instead of count, I can give the number of vehicles. And then I can able to print it out if you want. And then guys, we can able to give the go for the visualization. Okay. So I'll buy the top cities here. And then we're going to basically write the group by for the top cities one, or else instead of using the this one, I can able to directly use here the head part. Okay, like dot head of top 10. Okay. And then guys, we can able to basically have done the analysis. Now let's go for our figures. So plt dot figure. So figure I'll going to set as 12 by 6, 12 height and 6 width. And I'll use the bar plot guys, x equal to, I'll use the, what I'll do. Okay, let's check it out. For x equal to, I'll use the number of vehicles. Okay, so x equal to number of vehicles, y equal to I'll set as a city. And hue will be the country, and data will be guys like top cities. This one. This will be the our data which we are taking, right? Whatever the analysis we are doing. And let's set the color as a suppose we can set the guys some predefined colors. Okay, you can able to search the predefined colors by using the palette attribute, and I can able to set as a magma. Okay, previously I was using the Redis, I'm using now as a magma. Okay, the magma color, the title top 10 cities with the most electrical registered, and number of guys, this one on X label, I want to show basically number of vehicles has been registered. Okay, so vehicles registered, and the Y label I can show as a city, and for legend I can show as a country. Okay, city, and for this I can show as a country. And now let's guys understand Okay, so we got some kind of an key error. You can see here data equal to country. So let's go here in our data and let's check it out whether do we have the country, guys. We have the county here, not a country. So let's use the county. I'm basically using this variable. So let's change the everywhere wherever we have used it. Okay, so it will not going to show us some errors. We are done with the things. Let's run the thing and let's visualize series. Again, it's saying series object has no attribute to reset underscore index. Okay, so the spelling is wrong. So guys, check out the variable name, spellings, and everything. Okay, okay, guys, you can see now. This is the country we have counting, and this is the city, and this is the number of vehicles has been registered in these cities. Okay, and this is the complete view, guys. So in Seattle, Belleville, Redmond, Kirkland, Sammamish, Renton, Bottle, Tacoma, Tukwila, and Kent. These are the cities we have inside the particular countries. Okay, with the number of vehicles has been registered. Can you see? And this is the county: Kings, Commission, Pierces. So you can see, guys, these are the top 10 cities with the most electric vehicles has been registered. And here, this particular graphs basically show that the three countries we have, that is Kings, Commission, Pierce, guys. Okay, this is the horizontal bar which are representing the cities and their length corresponding to the number of vehicles has been registered. Okay, and here you can see, guys, a Seattle, which is a king country. Okay, king county. It has the highest number of vehicles registered by the significant margin. Okay, which is far outpacing the other cities listed here. Right, and then we have the Belleville and Redmond, which is also in the King County. Then, guys, next we have the citizens Communish country, right? Like Kirkland and Sammamish, which shows some moderate EV registration. Then we have the guys Tacoma and Tukwila, that is registration as a Pierce country. And the majority of the guys cities are shown from the King County always, like as we can see in the graph intelligence, right? Which is dominating the electric vehicles over this particular country. So this is the particular graph we can have. Now, guys, next we can explore we can analyze, guys, distribution of electric vehicle type. Okay, it means the types of electric vehicle registered in the particular, understanding the breakdown between the electric vehicle types as well as like such as battery electric vehicles, then plug-in hybrid electric vehicles, which can equal to, guys, provide insights into consumer preferences. Okay, which kind of an adaptation they want to basically apply, which patterns basically they want to purely electric versus hybrid, they want to basically want a solution. So we're going to basically visualize the distribution of electric vehicles types to see which categories are the most popular among the electric vehicles. Okay, so analyzing the distribution of electric vehicle types. Yes, so distribution of electric vehicles types. Okay, so I'll take the electric vehicle type. Okay, and then I'll take again the figure, guys, a plt.figure. I can able to set as a 12/6. If you want, it is able to reduce the number of, here I'll use the 10/6. That is also 5, 10 and 5. Okay, then I'm using the bar plot again, and then I'm setting the x-axis and then the y-axis, guys. And then I'm also basically setting the plateau as a radius, or you can able to set the next plateau as a rocket. So there guys, some particular templates that has been given, you can able to find in the Google. Okay, so these are the templates basically I remember because I have worked upon this kind of templates, guys. So that's why I can able to give you this kind of an intuitions. Now plt.title, plt.xvehicle, and then let's give the y vehicle as a type, number of vehicles, and vehicle types, and then, guys, we can able to show the things. Okay, so the title will be the distribution of vehicle types. X label can have a number of vehicles registered actually. Okay, so it can have the number of vehicles registered. Okay, and this Y label will be electric vehicle type, electric vehicle types, and this will be done. So let's analyze without using, yeah, perfect. You can see all of you. So this is the electric vehicle we have, battery electric vehicle, and this is the plug-in hybrid electric vehicle, guys. The battery having the more preference over the, guys, a public electric vehicle, right? So you can able to see in the United States, battery vehicles having the more preferences than the plug-in hybrid electric vehicles types, right? So now we got it here. Okay, now, guys, we're going to basically let's look at having the most popular manufacturers we have. Okay, so analyzing the most popular manufacturers. Popular manufacturers. Okay. Then, and then we can able to go for the distribution. I'm going to take a make, guys, the most manufacturers we have, the famous one. And then let's go for the some figure. So I'm using the 10 by 6. Okay, I'll use the again a bar plot. Bar plot will be fine for me. Sinus dot bar plot and x equal to I can give the manufacturer index as a 10. And then y equal to I can guess as a 10 data and apply it. I can able to use the rocket, or guys, uh we can also use one more template which is usually called as a cube helix. Okay, so that can give a very good number of palettes or colorings. And then guys, these are the things we have. Okay, now let's basically analyze the our bar plot for this one. Okay, perfect. Can you see all of you? This is basically, so if I can see Tesla, guys, Tesla basically leads by a very substantial growth, right? A substantial margin we have with the highest number of vehicles has been registered here. Then we have the Nissan, then we have the Chevrolet, then we have the Ford, BMW, Kia, Toyota, Volkswagen, Jeep, and the Hyundai. So you can see everything is given here, right? A complete analysis and how much it is there. The exact number is also we can able to find around 79,000. Basically we have for the Tesla. Okay, a very substantial, considerable margin we have compared to the other manufacturers. Now we're going to guys basically analyze the top 3 manufacturers based upon the I can able to see based upon the firms. Okay, so I'll basically understand the market size and trends in order to the most popular models we have. Okay, so most popular you can say selecting the top 3 manufacturers based on number of vehicle types. Number of vehicle types registered. Okay, so you can avoid the guys spellings. Okay, so basically let's cover up the things here. And if you're going to see this one is specifically for the analyzing this one top 3 makers, guys. Okay, that will going to give the I'm going to first calculate the distribution of electric vehicles among the top manufacturers. Okay, and then I'm going to start with guys figuring of it. So I basically started with the distribution of top manufacturers in the data of electric vehicle type, and then guys we can able to start with the number of vehicles registers and electric vehicle types for this one. So I can able to see. Okay, so this is the electric vehicles. So we have already calculated here. So let's give the top 3 here. Okay, so here what I'll do, I use the manufacturing indexes, guys. So top 3 manufacturers I can give, a top 3 makes we can give instead of giving the manufacturer. Let's say the makes. Okay, so EV underscore make distribution. So we can able to check out this one. Okay, and let's delete this one. So distribution dot header I'm taking as an indexes, and then we can able to use the top mix data. Okay, so top mix data in the top 3 makes. Then it is not defined. If we make distribution is not defined, distribution. Okay, we have the manufacturer distribution here. So guys can able to okay, so we can take this variable here and we can able to put it here. Yes, from here I'm taking the things, and then we can able to check out the things here. So let's visualize the top models. The top models we have with us, and the top models will be, I guess, I can take from the EV model distribution only. Okay, so top EV data, and from this I'm going to take some a specific value like up till head of 10. The first 10 I can able to take the top models, and I can able to start with the like figuring with the things. So PLT dot figure. So the figure will going to give me the figure size. Then I can use the bar plot. That is for the x-axis, I can use the guys number of vehicles. Okay, for the y-axis, I can take the model. U will be the make, and data will be the top models. Okay, palette, guys, you can say as a rocket or this depends upon you. Title will be the top 10 models, I can say, with the most electric vehicles, you can say. And the number of vehicles has been registered for the X label. The number of vehicles registered, guys, registered, and the model we have and the rotations and for the make one. So let's check it out. Okay, so we got it from here. Could not interpret the number of vehicles for the x-axis. Let's see what kind of an issue we are getting. The number of vehicles, y equal to model. Okay, so what we can do here, we can able to go for the group by things. Okay, that we have to, guys, analyze the model distribution first of all. Let's analyze the model distribution. So EV model distribution. Okay, so EV a model distribution for the top mix we have to analyze. So by using the group data in this one, and then for the top models we can able to find this one. Okay, so let's use this one for the top head data, and then let's select the number of vehicles, guys. Okay, so you can see the model Y, model 3, and model leaf, guys. These are the 3 top models we have for the most electric vehicles has been registered for this company, right? So you can see we can able to analyze with the things very easily, right? Now, guys, we're going to basically look out for those things. Okay, like we're going to see the trend lines, how we can able to estimate the price of it, or like we'll calculate the, guys, compound annual growth rate between the recent year and the complete data, which we do it, and then we can able to start with then we can able to conclude the things how basically we are dealing with the strategic decisions of it. Okay, so we'll calculate the compound CAGR, okay, between a recent year here with the complete data. Okay, and the first year also you can take for the projected year for the 2020-24. Okay, so guys, for this we required a SciPy. So from SciPy we'll import the optimized model. So from the, guys, SciPy is the scientific Python library which is used for the basically calculating the different formulas. Okay, so we can use the SciPy and the NumPy. NumPy is again a numerical Python which is usually used for some most of the things. Okay, so you can able to take the filter here, and then, guys, we can able to take out the filter here for the 2023, and then we can able to drop it here, and then, guys, you can able to use the exponential growth for it, and then you can able to calculate the CGR for it, and then you can able to, guys, use the data in order to prepare the CGR. Okay, so you can take the X data, and then you can able to find the Y data. Okay, and then, guys, you can able to use the parameters for it. So params dot curve fit, done. Okay, so params and covariance will be there, guys. Okay, params and covariances, and then I can able to set the curve fit, guys. So I can find the curve fit here, and then we can able to give the forecast years, and then forecast values. These 2 things we're going to get, and then, guys, we can create a dictionary for it. So forecasted EVs, and then I'm going to create a series for it, and then we can able to, guys, print it out the series for this one. Okay, together with the shape. So we got some here kind of an error here with the Y data. So filter here dot, okay, so filter here dot, we can take the values instead of taking the filter here. Let's say could not convert string to this one. Okay, so we can able to check out the errors where we can able to solve the error one. Okay, so let's try to make use of some AI, and let's try to analyze like which kind of an error we are getting. So here I'm using the X data for the filter one. Next one, let's check it out here. Okay, so it's saying this is the things should there. Perfect. Let's calculate this one. Okay, so you can see that's 575919 for this one. Then we have the basically we have to check it out through the recent years. Okay, so recent year for the 2023, and this is the X data, guys. We have taken. We haven't basically given the Y data has this one, the electric range, and then guys, you got some kind of an values here. Okay, so this is the plotting. Now we can able to do the plotting of it. Like we have to basically analyze the number of actual EV registrations over the different types of plotting fields. Okay, or then we can able to estimate the market size of the analysis of electric vehicles in the United States. That we can able to at least do it. Okay, so we can able to calculate the number of electric vehicle registers for those counts. So if I use the EV registration counts for the EV data, guys. Okay, for the model year. Okay, for the sort indexes I'm doing, and then we can able to set the registration counts. Now we can able to get our for the model year how many particular electric vehicles has been registered here, right? So this will give you the at least a quick view over the entire analysis. Okay, so guys, this is you can say given the growth trend, we can able to find that EV registration and projected acceleration for the forecasted data. Okay, we can conclude that guys, EV market size is expected to expand considerably. Okay, and it also basically gives you the promising results where that EV registrations can be continued to rise. Okay, so if you want, you can able to plot guys and estimated registrations for also like some kind of an estimated means a plotting part. Okay, so you can able to find the estimated predictions. So estimated predictions over the data. Okay, and then what you can do, you can able to use the years for it in order to take it and without range and taking the range from filtered years. So from 2023, 2024. Okay, you can take the 2025. Okay, so this kind of guys you can be able to take 2028 also. This is also fine because we are predicting for the actual years. Okay, actual years you can able to take here this one. Okay, so you can be able to take the actual years and then you can able to forecast the year here. Okay, forecast years, and then guys you can able to deal with the things here. Okay, so in forecasting year you can able to take the np dot range from where to where you want, and then you can able to set it the things 2004 to 2000, suppose 29 plus 1 you are taking here, right? 2000 plus 1, and then you can able to like forecast the guys of values between the years. Okay, then you can able to plot the things. Okay, so this can be guys of an assignment, like you can use the line chart for it and plot the actual years versus the predicted years. Okay, so I hope like everyone have got it. So we'll meet with next particular session with the next wonderful project. Till then, bye bye.